For this video, we are going to talk about work and energy. So first thing we need to address is what is energy? So energy is just the ability to do work. So if you're burning energy, then you're doing work, which we'll get a little bit more into that here soon. Work and energy, both of these are scalars. So if you remember from last semester, scalars have magnitude only, so it's just some number. Only. Where if it's a vector, then it's going to have magnitude and a direction. So these, you don't have to worry about the direction that work is being done. Both energy and work are measured in the same unit. It is the joule, or joules. It's named after a French scientist. That's the reason why it's spelled different than the gemstone joule. Now we can talk about work. So work can be defined as either a change in energy, which would be W equals delta E. And if you remember what the delta stands for, it just stands for, so this triangle here is a change in. So you would just take the final amount of energy minus the initial amount of energy. And we'll talk about that more when we get into different types of energy. What we're going to be using more of right now is if it's the product of a force terrible and signed, and direction. So our formula is W equals F times by D. However, there is another formula that we can use. Really, this is just a simplified version. If you're pulling something at an angle, so for example, if you're pulling a little wagon, so this is our wagon here, got the handle, and you're pulling it along, technically you're pulling it along at some angle. So this angle here, and not all of our force is being used as work, and I'll talk about that in a minute. So if something's being pulled at an angle, what you're going to do is you're going to use this equation here. It's going to be work equals force times by the cosine of some angle times by your distance. Technically, you're doing the same thing up here, but the cosine disappears. So if you take cosine of 0, it should be 1, so it kind of makes itself disappear. So we don't end up using it. All right, so in physics, when we're talking about work being done, so if I hold a 30-kilogram weight at a height of 1.5 meters, you could technically say I am using energy. However, the work is not being done on the weight. It's being done on my muscle. So if you think about it, there's no weight being done on this weight. So a way of thinking of it is, although that they're exerting a force on a weight, so a force on a weight, its distance moved is 0, therefore no work is being done. That is the big thing with this, is your force and distance need to be in the same direction. So force and distance in the same direction. So I know there's not a lot of room there to write that, but write that off to the side somewhere. That's the big thing on these. So if we start looking through some of the problems, before we tackle this, I need to actually go over the formula with it. So like I had said, so we're going to look at this box here. When an object is lifted against gravity, we can use this formula here, work equals force times distance, but we can also do it, calculate it out as work equals mass times gravity times by a change in height, which really is our distance. So the big thing to keep in mind, force, we can say, if you remember back from last chapter, force of gravity equals mass times gravity. So we're just taking this part here, and plugging it in, and then just changing it so it's in terms of height. It's really just reworking the same equation to get us something a little bit easier to use. So again, some of the things to keep in mind. So with M, it's mass, and it does need to be recorded in kilograms. G is gravity. You can use 10 meters a second squared on that one. And then H is your height, which needs to be measured in meters. And in all reality, it's a change in height, which for the most part, whatever we give you as the height is the change in height. So when we look at this middle example here, so if I were to lift 30 kilogram weight up off the ground to a height of 1.5 meters, how much work is being done on the weight itself? So let me just draw a quick picture. So we're applying a force up to pick it up. We're going to move it a height of 1.5 meters. So we're going to use the formula. Let me switch colors here. Weight equals mass times by gravity times by height. Anytime we're dealing with picking something straight up in the air, we're going to use this formula. So when we go to look back at our problem, our mass is our 30 kilograms. Our height is the 1.5. Gravity we always know is 10. So we can plug in our numbers. So 30 times by 10 times by 1.5. Let's see here. I did not have a calculator handy. Should be 5 joules. Should be our answer. 450 joules. So that's how you would set this one up. All right. For the other ones, you'll need to watch part 2.